not parallel to the floor or to the snow like in the first case here, right? It is not parallel to the snow. So we want to calculate the same thing. How much is the work done against friction? How much is the net work done? We're going to go through the same process. Okay. Oh, although we go through the same process, but the situation is different now. Now, why I say the situation is different now? We look at the force diagram, right? The force diagram, this arrow here. You look at this arrow here. The force exerted by the man is acting at an angle of 30 degrees with the horizontal. Now, like what we have learned earlier on, this force of 120 newtons, you have to resolve them into two components. One component which is perpendicular to the floor, and another component that is parallel to the floor or parallel to the surface of the snow. So we resolve this 120 newtons into its two components as shown here. Well, what is the significance of resolving them into two components? The significance is the force, the applied force, is no longer the full force. Earlier on, the applied force here is the full 120 newtons. But in the second case, the applied force now is only F cos theta, the horizontal component of the 120. So you are applying less force to move the object. This is the first consequence of having a force acting at an angle with horizontal. Now the second consequence is this force F sine theta. This force F sine theta, although is not involved in moving the object, but it helps to lighten the burden. What I mean by lighten the burden, we know that the force acting downward is the weight mg. Now, if the force is acting horizontally, then this mg will be equal to the normal reaction. But because of this F sine theta acting vertically upward, it will actually reduce the normal reaction. That means when your weight is acting downward and you're pulling slightly upward, you are actually helping to lift up the load. So the contact between the load and the surface become less. So the normal reaction become less. So these are the two consequences of having a force acting at an angle. Okay, so we look at the first significance. The first significance is the applied force, this one, the horizontal component. So I try to calculate the applied force, the force that is going to move the object. Now, because the angle is adjacent, so we use cos theta. Okay, so F cos theta is the one that we want to find out because it is the applied force. So 120 cos theta is 30. So using the calculator, we calculate the applied force is now only 103.9 newtons. If you compare with the earlier case, the full force is applied force is 120 newton. Now we have only 103.9. Okay, next. I am also going to calculate the normal reaction, right? So the normal reaction is mg minus mg sine theta, right? Because the burden, the load will be lessened by mg sine theta, because mg sine theta will be lifting up the load. So the normal reaction is now not mg, but mg minus mg sine theta. Okay. Then what is the frictional force? This is the this has an effect on the frictional force. The frictional force is the mu times n, the coefficient of friction multiplied with the normal reaction, right? This is not mg sine theta. I typed wrongly. This is f sine theta. Sorry. This is f sine theta. Sometimes I type wrongly. Okay, so the normal reaction is mg minus f sine theta, the component of the force that is lifting the load. Okay, so now we want to find the frictional force. The frictional force is mu times the normal reaction. What is the value of mu? Negative 0.2. What is the normal reaction? mg minus f sine theta. So I try to substitute in all the values. Mu, I substitute with 0.2. The weight, m times g, 50 times 9.8. Then the component of the force, f sine theta, 120 sine theta. So using your calculator, you try to evaluate this, and the frictional force is 86 newtons. Because the frictional force is in the opposite direction, so you have to put a negative sign there. So this is the frictional force. What is the work done by the frictional force, or work done against the frictional force? You have to multiply with the distance. Okay, so work done by the frictional force is F times D. So we have found out the F. One thing, now you have to note that, take note that or maybe the book, they use small f to represent friction, capital F to represent the applied force. So there is a difference between capital F and small f. Capital F is the applied force, small f is the frictional force. So we want to find the work done by friction. So work done by friction is F, the frictional force, multiplied with the distance. And answer is 430. So it is less than the earlier value that we have found. Earlier we have found negative 490. This one is negative 430. Why is the frictional force less? Because the normal reaction is less. The contact between the surface of the snow and the load is less. That's why the frictional force is less. Any questions so far?
No question, sir.
No. Okay. No, then we look at the net force. Net force, right? So this diagram will show us the net force. So we know that the applied force is now only F cos 30. So this is the applied force, F cos 30, which we have calculated earlier to be 103.9. Okay. Then we look at the frictional force. Frictional force is this one, mu n. Okay, mu n is calculated here, negative 86 newtons. So to find the net force, or the net work done, we try to find the total work done. Okay, total work done is our applied force. This one, the F is our applied force. Multiply with the distance moved. So the applied force is now 103.9. 103.9. Multiply with the distance moved parallel to the applied force, 5 meters. So the work done is 520 joule. But they want to find the net work done. Where is it? They want to find the net work done. So the net work done is not 520. 520 is the work done. Okay. So the net work done is the total work done minus the work done against friction. Total work done 520. Work done against friction is 430. So the net work done is 90 joule. Any questions so far?
No.
So let me summarize what we have done so far. We have looked at two cases for work done. The first case is when the force is parallel to the surface. So the applied force is 100% of the applied force, 120 newtons. In the second case, the applied force is acting at an angle. This result in there are two significant consequences of this applied force acting at an angle. The first one is the force that is actually doing work become less. The second significant is the normal reaction also reduced. So these are the two significance, and we have to calculate accordingly. The normal reaction you will calculate taking into consideration the vertical component of the applied force. The work done you have to take into consideration is just only a component of the applied force, not the full force.